Okay, so pardon me for plugging my recent 600-page book. I'm doing it, I can't make any money off it, I'm a government employee. Um, Basically, I'm telling you about this. You don't have to buy the hard copy. It's available for downloading from many libraries. It will have a lot more information on some of the topics I'm going to be talking about in the next half hour. So I'm going to start off in a very elementary fashion with the kind of introduction you might get in a pharmacology or pharmacognosy course. The lecturer might begin by saying, medicine used to be very primitive, very old-fashioned. We were all dependent on crude, natural medicinal materials, particularly just ground-up plants. But today, at least in Western medicine, we're much more advanced. We have highly purified pharmaceutical substances, with the implication that these are necessarily superior. And there's another factor that is often associated with herbals as opposed to purified pharmaceuticals, and that is simply the reputation. And that's particularly evident, isn't it, with respect to marijuana. Marijuana, in its basic form, is a crude botanical drug. And it has a lot of stigma attached, as is clear. So it's often, in some circles, referred to as a witch's brew. And in fact, many herbals are sort of pejoratively characterized in this fashion. And it certainly is true that there are a lot of different materials, perhaps hundreds of different materials in herbals, and the safety and efficacy of many of these is suspect. But the fact that something is a mixture, a herbal mixture, isn't necessarily bad. Now, on the right side of this slide, I've shown tobacco, and I don't think anyone would defend the materials in tobacco. They are awful, especially when combusted. On the other hand, coffee is also a mixture of many materials. Many years ago, I recall seeing a paper that said there were more than 400 carcinogens in coffee. But today, coffee is considered benign, if not indeed therapeutic. The fact is, just because something has a lot of chemicals in it, we are, like many animal species, adapted to withstand a regular intake of small amounts of toxins. Our liver, our kidneys get rid of a lot of the toxins. Now, before leaving this topic of a lot of chemicals being in raw marijuana, I want to talk briefly about interactions of compounds. Now, such interactions may be beneficial or negative, and perhaps the most instructive example is the interaction of CBD and THC, which in some quarters at least, is considered beneficial. And I will later be talking in a little more detail about the interaction of terpenes and cannabinoids. And you will be aware almost certainly of the entourage effect, which really is not a new idea. It's simply a statement that there may be beneficial interactions between cannabinoids and perhaps cannabinoids and other classes of chemicals. The only problem with this theory is demonstrating its validity. Now, I'm going to make one other general point. We had a lot of discussion yesterday about the differences between recreational and what I'll term professional usage, and I'm not going to get into that as an argument, but simply to point out that there's an area of overlap. In fact, it's a much greater area of overlap than I've shown here, because as you know, a huge amount, the major amount of quote unquote medicinal usage of marijuana is by self-diagnosis and self-treatment. And I point that out simply to say that the modalities of application in this case are that most people use crude marijuana. And the most common way of consumption is smoking. And I don't think anyone's going to defend smoking as a way of ingestion of a medicinal. And indeed, the passion yesterday, which some people in the audience defended the need to have a separate stream for truly medicinal usages, I think is justified in that there are obviously going to be ways in the future, and even developing at present, of administering cannabinoids, cannabis, that are very efficient and, dare I say, in many cases, expensive. Now, a little more about strictly botanical aspects. So cannabis is an unusual plant. Most plants have male and female plants on the same plants. Only about 5% are like cannabis, with some plants, half of them, developing only male flowers, and the other half developing only female plants. In the world of marijuana, male plants are generally despised. First of all, they only produce about 1/20 of the amount of THC that the females produce, and more particularly, their pollen fertilizes the female plants, causing the development of seeds, which really is an adulterant because it diverts the plant's energy into production of seeds which don't have THC, and so it's not a good thing from a productive point of view. Cannabis is basically used for three purposes. There's a fiber in the stem, very easy to pick out. You can actually just pick it out with your bare hands. There are the flowers that are associated with the drug usages, but there's a complication I'll explain. And there is the seeds, which are used for food, and cannabis. Canada has in fact become the world's premier producer of high-quality seeds. Now, I said I was going to say something about the flowers. On the left of the slide, notice the canister with the expression cannabis floss, literally an old pharmacological term for cannabis flowers. On the right, there's a bud. And basically today, the foliage is not much used. You use the ground up flowering heads, and you would grind this up, and that would be cannabis floss. There is a female flower in the center of this slide. And one of the points I want to make is that the cannabis female flowers are completely devoid of cannabinoids. I know that the marijuana is often called flower or flowers, but technically speaking, the flowers are completely devoid of cannabinoids. However, at the very base of the flower, there's a little leaf called a bract, and on that there are epidermal appendages which produce the cannabinoids, and I'll have a little more to say about that in a few minutes. But it's the flowers that I'm going to discuss in a little detail now, because there's something about them that deals with the possible therapeutic values and toxicity of cannabis that I rather imagine is completely unknown to everybody in this room except me. But you'll soon be as knowledgeable as I am about that. The flowers, the female flowers, are extremely simple. At the base, there's what's called an ovary. That's comparable to the uterus of an animal, and in this case, it'll only develop at most, if it's fertilized, one seed. And then there are these long threads called stigmas, which are what receives the pollen, the male elements. And I like to compare the stigmas to vaginas, although they're rather extended. But the point is they're a passage for pollen to grow through, and that's exactly what happens. Pollen lands on the stigmas. Literally, there's a tube that grows right down until it meets the ovule and fertilizes it and produces an embryo, a baby plant. all those reddish things in the bud, those are dried up stigmas. There's a lot of stigmas in marijuana. Now, I'm going to tell you a little about corn because it's relevant. A corn cob is a mass of flowers. There can be as many as 1,000 in a corn cob. And every grain, every embryonic grain before it's fertilized starts to put out a single stigma. In this case, the stigmas are what you would know as silks. And these silks can grow very long. They're more than a foot long here. The idea is that these silks grow in anticipation of meeting a pollen grain and getting fertilized, because if they don't get fertilized, the grain on the corn won't develop. And corn farmers know that if they let the grain, if the silks get very long, they know that they're not going to get good corn because there isn't enough pollen in the atmosphere. This is a wind-pollinated plant, just like cannabis. So these silks, it's almost as if, excuse my expressing it this way, but the plant vaginas are getting frustrated that they're not fertilized, so they're growing larger and much longer in the hope of meeting a male. Okay. These silks, generally people don't like to eat them. They'll use perhaps a toothbrush to rub them away. You can carry that away as a particular point of knowledge. And these silks have particular significance because they are commonly used in herbal medicine. They're often used to treat kidney problems, urinary problems in general. So there are indications that they have medicinal values. They are also potentially toxic. Something that has both therapeutic chemicals and toxic chemicals is something that you want to be on the lookout for. Now, what about cannabis? I'm an adjunct at Ryerson University, and my student, Steve Naray, and I recently published a paper in which we pointed out that cannabis is like corn. Amazing that no one had understood this before, but the stigmas on the left, they're white and they're growing. They will continue to grow just like corn. They won't get a foot long like corn cells, but they do get quite long. And before I discuss the implications of that, let me give you one more example of stigmas. This is the saffron crocus. Now, saffron is a spice. It happens to be the world's most expensive spice. A unit weight of saffron stigmas, and it's just the stigmas, in some years is more expensive than a corresponding weight of gold. Well, with something that expensive, you can't use very much, and fortunately you don't have to use very much, and saffron is used to flavor a very large number of ethnic dishes, bouillabaisse, a whole bunch of other things. You don't use very much, and indeed, if you use a lot, you can get quite sick, and people have died from overeating on saffron spice. Again, another example of something that is used in herbal medicine as a therapeutic, but also has significant, toxic potential. So what about cannabis? What about those stigmas? We found that as much as 0.5% of current marijuana buds on the marketplace can be made up of these stigmas. Now, I don't want to be alarmist. We don't know if they're toxic. We don't know if they're therapeutic. Absolutely no work has been done on that. There's no literature on this. Don't you think that's an area that deserves research? This is a slow clicker. Okay, got it. I'm next going to go on to describe the structures in which the cannabinoids are synthesized. Now, there's a term called trichome. In animals, one talks about hairs, and with a lot of hairs, you can be quite furry. Plants are generally not furry. If you have a lot of fur, the light won't get to you, and you won't be able to photosynthesize. There are far fewer hairs in cannabis, and they're generally not called hairs. We like to call them trichomes. There are quite a variety of trichomes in plants, and some of them have a little gland at the very tip, and that's very common. There are actually more than 100,000 species of plants that, like cannabis, are hairs with a little glandular tip. They kind of resemble, in miniature, a golf ball tee with a golf ball on top. And if you do a longitudinal section of that, there's no cannabinoids in the stalk. The hemispherical head at its base has biosynthetic cells which produce terpenes and cannabinoids. They're shown in red. And after a while, they excrete a resin composed of the terpenes and the cannabinoids into the body of this head. That's shown in green. We've found that the most productive strains of marijuana have high densities of these secretory trichomes. Very frequently, they have very long stalks, and the gland heads can be much larger. We found that they can be 4 times as large in volume as much less productive strains. And this is not unexpected. These are the working parts of the plant that produces these cannabinoids in a very productive strain. This is the kind of thing you would expect. Well, from the plant's point of view, what are they there for? They are adaptive. In cannabis, I said that 100,000 species of plants have these gland-tipped hairs. Very, very few of these are like cannabis, in which there are so-called touch-sensitive glands, which means when anything touches them, the gland head explodes, scattering resin over top of whatever touched it. And at the extreme left on the bottom, a little insect has become stuck on these glands where it'll die. This is like flypaper. This is the purpose of these glands from the plant's point of view. A larger insect, such as this moth, would get sticky, would get discouraged from eating the plant, and would fly away. Again, this is a phenomenon which is, we recorded in the literature 2 or 3 years ago, but for whatever reason, nobody had seen fit to publish. If you want to demonstrate this yourself, you'll need a fresh green growing plant. Dried marijuana, this reaction is completely inert. You won't be able to demonstrate it. So plants, like all species, develop a phenotype that is the result of nature and nurture, of genes and the environment. And of course, we now know that there are epistatic reactions. Sometimes environmental influences cause switches, gene switches to turn off or on, and that can have genetic hereditary effects. But regardless, environmental influences are a topic that has been discussed with respect to influences on cannabinoid quality. On the right, I've shown this young lady in her garden. Plants are pretty simple, which frankly is why I became a botanist. They don't require much care. Just put them out. They need water, of course. They benefit from fertilizers. And very early in my career, I took a clone of high THC marijuana, split it into different pots, and subjected those experimental pots to different levels of fertilization. In fact, certain key nutrients are probably the most important environmental factor determining the growth of plants, including cannabis. And here I subjected the plants to extreme deficiencies of nitrogen, phosphorus, and potassium. And as you can see on the extreme left, the plants that were deprived of nitrogen and phosphorus were quite dwarfed. But when we looked at the cannabinoid profile, actually the THC content had slightly increased. The point I'm making is that cannabinoid development in cannabis is pretty resistant to environmental influences. On the other hand, clearly, these influences are critical in terms of the productivity of the plant. These tiny plants are hardly what a marijuana producer is interested in growing. Just to give you another example of environmental influences, I said that cannabis was extremely important as an oilseed in Canada. Well, climate does influence oilseed quality. Oilseed quality is basically to do with the fatty acid profile. And as you know, unsaturated fatty acids are healthier than saturated fatty acids. And cool climates, such as Canada, promote the development of unsaturated fatty acids. You grow the same material in a more southern hot environment, and the fatty acids are much more saturated, which is unhealthy. And this is actually a common phenomenon in oilseed plants, and it's a great advantage for Canada, which is one of the reasons why we are one of the world's great oilseed producing countries. While I'm talking about oil, let me point out that it's a very ambiguous term, and people often get misled by it. So here are the three basic meanings. There's hemp seed oil, which is a vegetable or fixed oil. It doesn't evaporate, and it's edible. There's essential oil. Terpenes are essential oils. They are volatile. They evaporate. And then there's what everybody here has just been casually calling oils. These are perhaps more technically termed hash oil or hashish oil. They're concentrated extracts. And just a further point, hashish oils are often not oily. Oily implies a certain liquidity, but some of these hash oils are charry. And I don't know whether you've heard the expression shatter. Something shatters when it's a solid, and that's a form of what people include in oils. So some information now about the generation historically of THC and CBD in various strains. Cannabis originated in Eurasia. Probably the ancestral type has vanished. This is actually quite frequent amongst our major crop plants. The ancestor just has vanished from the face of the earth. It's become extinct. Probably in very early times, when humans were nomadic wanderers, they discovered that the fiber from the stems, you can, as I said, easily just pick it out. You could use it to make ropes, fishing nets, very easily. And you would quickly have discovered in those hungry times that the seeds were edible. And I suspect, well, somebody was roasting the seeds over an open fire, an intoxicating fume arose, and that became the basis of another industry. So in very early times, two basic classes of plant came into existence, one for fiber and one for drug. And before European settlers in the 1500s populated the Americas, the pattern in the old world was probably more or less like this, that in relatively northern parts of Eurasia, the fiber type, which is very low in THC and relatively high in CBD, was prevalent, and it was used for fiber, not for drug purposes, although pretty well every plant that was cultivated in past times was used for dozens, if not hundreds, of medicinal of medicinal purposes. But towards the south, the intoxicant type of high THC plant was prevalent in southern Asia and around Africa. But it's a little more complicated than that. And this is a pattern that also develops quite frequently in important crop plants. That is, that people will carry the plant to a given geographical region and develop it there in very specialized ways so that the local plants are distinctive. And there are distinctive kinds, at least there were historically. The low intoxicant type, there's a distinct European hemp, and on the other side of Eurasia, there's a distinct Chinese hemp. And similarly towards the south, there are two kinds of marijuana, which you've doubtless heard as sativa type and indica type. To complete the picture, in more recent times, there's been hybridization between the low THC hemp types, which have obscured the differences, and the same thing has happened between the high intoxicant THC types. They've been extensively hybridized, obscuring their differences. In ancient times, the much less frequent indica type was prevalent probably in regions of Pakistan, Afghanistan, India. And this is what they probably looked like. The indica type on the left is a much more compact, shorter type. The sativa type on the right is impressively large, but it's a more primitive, less advanced type from an agricultural point of view. It's huge, but it's wasting a huge amount of energy in producing stem tissues. The indica type tends to have a fair amount of CBD as well as THC. So in some respects, it's also a superior kind of therapeutic plant. I'll just mention in passing, I pointed out these rather impressive architectural differences. On the top, I've shown architectural classes of low THC hemp. On the bottom, architectural classes of high THC marijuana. I've recently published a paper, and this is from that. I'm not going to say more on that, simply to point out that in the world of agriculture, cannabis has been neglected for so long that, unlike all other crops which have had this kind of specialized breeding, we're now in a position to make these very specialized architectural types which are superior for certain breeding and production purposes. So some remarks about CBD, which I would say in the last 5 years has turned into an enormous cash cow, like this goose that lays golden eggs. And I think a lot of it has to do with the rather impressive case of this little girl, Charlotte Figge, who suffered from Dravet syndrome and whose symptoms were alleviated by a high CBD oil. So more recently, we actually have GW Pharmaceuticals producing Epidiolex for treatment of epileptic diseases, and I rather expect that it's very expensive, like Sativex. But the cash cow aspects I was talking about was that kind of bottle in the middle called Charlotte's Web. People have been producing CBD oils in their kitchen and selling them kind of as an over-the-counter preparation. And this is where industries are anticipating that there'll be not pharmaceuticals, over-the-counter, basic do-it-yourself stuff, which in a way is kind of discouraging, but it's the reality of the situation. And at the moment, this kind of low-grade over-the-counter stuff is being peddled extensively in the States. Some people estimate the value of CBD preparations alone as billions of dollars. I was at a conference in Colorado last year, and someone passed around a little vial of crystalline CBD and said it was worth millions. Well, that was kind of brave, but he managed to get it back. This is another manifestation of CBD. Now, with this great interest in CBD, People very recently have taken high THC strains and have bred them to become high CBD strains. And Agri-Food is such a strain produced in Israel. And rather interestingly, they call the herbal material Hylas marijuana, which is a bit of a misnomer because marijuana is generally associated conceptually with something that gets you high. Probably Hylas cannabis would be a better term. And in any event, this is not popular. People don't particularly like to smoke stuff that doesn't get you high. But even if it has medicinal qualities, an oil extract is much more sensible. Now, there are two basic classes of plants that can be used to obtain CBD. On the right, I'm showing you plants that are being grown in Colorado right now. They are of the kind that I just mentioned. They're selections from originally high THC strains that have become high CBD strains. The reason you do this, rather than just using hemp, is that high THC strains have a natural ability to produce a lot of resin, and you want a lot of resin. The alternative to that, which is kind of experimental at this point, is that you can just use plants that you are growing for hemp, particularly for oilseed, because the little bract that's loaded with THC that I was telling you about, that's closely associated with the seed. So after you've harvested the seed in an oilseed plot, which is shown at the left, the remaining stuff, which is today just thrown away, you can use that to extract CBD. It's kind of sensible. But you can't do that yet in Canada, but hopefully you will be able to do so quickly. And as I say, now my suspicion is that, yes, it is a multi-billion-dollar industry, but I think this is a bandwagon that won't last. Another topic that's important, remember I referred earlier to witch's brew, the fact that raw materials are composed of a large number of different chemicals, uncharacterized, potentially hazardous. Well, it's always wise to reduce your intake of these unknown chemicals. And with cannabis, one way obviously of doing that is vaporization, which is certainly superior to combusting and getting all these awful products of oxidation. Also, another way of doing that is hashish. Now, hashish is a high THC preparation. And in primitive times, it was prepared like this. The top illustration shows people who are just taking the flowering tops, sieving them through a very fine screen, and a powder is collecting at the bottom. And basically, they will compress that into bricks, and that's all that hashish is. But it's horribly unsanitary, and no one in his right mind would use this for medicinal purposes. There's another way of getting a very purified concentration, and that's to harvest the gland heads. Curious, there are several apparatuses, and I've shown them below, that have been created in the underground world. You can buy them now on the web. And these are ways of breaking off the glands and collecting them separately. And you can compress these into little cubes. I've seen preparations that are 40% or more pure THC. Now, this is actually a very inefficient process. It's basically a do-it-yourself home process. And the stuff you get is so concentrated that you have to dilute it. Unfortunately, people often dilute with tobacco. This is the stuff that you get. It's often called resin powder. And to its credit, it is relatively pure, but if you vaporize this, for example, you'd have to vaporize a very minute amount in order to have a dose. Hard to control the dosages here. Solvent extracts, frankly, are a much superior way of going about reducing the load of unknown chemicals. I'm getting close to the end. I'm showing you here a scene that I had my technician create because I didn't want to violate any copyright provisions. This is from Wizard of the Oz, And this is Dorothy. I don't know whether you can make out her companions in this field of poppies. The story goes that when Dorothy and the Tin Man, the Cowardly Lion, the Straw Man, I think there's a dog supposed to be in there somewhere too. They were walking through a poppy field and they were overcome by the fumes of the poppy. Now remember what a narcotic is. An opium poppy is kind of the epitome of a narcotic. If you looked in a dictionary for a definition of narcotic, you might get something like a narcotic is a very dangerous, addictive drug, or more frequently, a narcotic is what legislators decide is very dangerous as a drug, and they simply list it in a schedule, and whatever its pharmacological properties are really irrelevant. But pharmacologically, a narcotic is something that narcotizes, stupefies, basically makes you sleepy. And this is an illustration. It's actually an old wives' tale that fumes can be given off and put you to sleep. But here's a plant that may actually do that. And it happens to be the closest relative of cannabis. This is humulus, the hop plant. Hop is a high-climbing vine. And today, it's harvested mechanically. But in the past, field workers had to go out there and harvest the hops, the fruit which is used to flavor beers. And they often fell asleep. These are hops. They're 100% homologous with buds of marijuana. But the glandular trichomes in this case produce aliphatic acids, which are used to flavor beer, instead of cannabinoids. As you would imagine, people have tried to smoke these. So hop has a very substantial reputation as a soporific, putting people to sleep. And it's used in hop pillows. It's used in tinctures. And what's this all about? Well, there actually is a volatile alcohol. What's it called? I can't read it from there, but it doesn't matter. It's in very, very small concentrations. So small, and it's also evaporates quickly, so it probably doesn't have any effect. On the other hand, the terpene myrcene is present in hop in substantial quantities and may be the soporific agent, and this relates to cannabis. Now, you've heard of the alleged phenomenon of couch lock, which is a state of extreme lethargy. And people have tried to explain this as the result of consuming CBD and perhaps indica-type strains, which are often rich in CBD, are responsible. This is pretty well discredited. On the other hand, Ethan Russo has championed the possibility that myrcene, which, as I've tried to indicate, has some soporific qualities, reinforces the effect of THC to make people very sleepy and explain what couch lock is all about. My own opinion is that couch lock just means you're stoned. Terpenes are very, very important as far as cannabis is concerned. My authority on that is the internet. It is certainly true that terpenes have pharmaceutical properties. They also have toxic properties. Terpenes are of special significance as far as marijuana strains are concerned. You know what organoleptic properties are? These are, in terms of food plants, organoleptic properties are the properties of a food that make it attractive to consumers. As far as cannabis is concerned, the site, it all looks the same. That's an organoleptic property. The feel, there really is no mouthfeel to cannabis. You don't eat herbal cannabis. Basically, it's the aroma characteristics, a combination of taste and smell, that's important. And it's the terpenes that are important as far as cannabis strains are concerned. Thousands of strains have been recognized. Most of them, frankly, have no validity whatsoever. But in any event, the impetus for recognizing these as separate entities is largely their alleged differences in taste and smell. And there are real differences. And people are trying to breed particular strains with these terpene characteristics. The problem is that, first of all, the terpenes are volatile. So immediately you harvest, you start to change the terpene profile. And if you irradiate your material, as is commonly done for safety microbiological reasons, if you extract CO2 or whatever, you apply heat to make edibles, once again, you tend to drive off the terpenes. So I realize that terpenes are a big selling point with companies, and the development of all these strains with respect to their terpene characteristics is an important selling point. But to me, from a logical point of view, this is all nonsense. Strains are important for their differences in cannabinoid profile. They're also important for their qualities in terms of growing outdoors, indoors. But for aroma characteristics, I don't think that's important. Terpenes are present in all kinds of plants. The fact is, cannabis has no unique terpenes at all, and they're very expensive to produce in cannabis. Much easier if you want to flavor a given preparation of cannabis to just get some off-the-shelf, cheap terpenes. Now, as you know, at least in Canada, you can't compound cannabinoid preparations unless you demonstrate efficacy and safety. But this will come, and one day preparations which are presumably more therapeutic than those available now may involve compounds with terpenes and other compounds. As you know, the Achilles heel of cannabinoid therapy is that they are not silver bullets like many pharmaceuticals. They target so many organs of the body, but it may be possible with respect to combinations with other elements, compounds, to more precisely target cannabinoids. Finally, thank you for your patience here. It's sometimes hard to understand that we actually are in the midst of a fairly rapid revolution as far as cannabis is concerned. And I've been associated with cannabis and the government of Canada for almost half a century, and I can tell you that we are currently rapidly undergoing great changes. Still, we have this lingering bias against cannabis, and more tragically, a lingering bias against doing research of any kind on the plant. And it's such a pleasure to be amongst this unbelievably talented and sophisticated and motivated audience. So I'm going to conclude by congratulating us and wishing us Godspeed. Thank you.